6 more algebraic proof questions which you can download from the description down below. Hey there guys, welcome back to the channel. If this is your first time here and you're trying to get the best grade in maths you possibly can, let me help. Start now by subscribing. Okay, first up we have a geometric proof. So the diagram shows a triangle and a trapezium. We want to prove that A is equal to B. Okay, so looking first of all at the point where the triangle and trapezium meet, we have all of the angles around a point. We know angles around a point add up to 360 degrees. So the first thing we can say is that A add C add 65 add 115, which is 180. Must be equal to 360 degrees. Now, if we subtract 180 from both sides, we get A add C is equal to 180. Okay, so that's all we can do there for now. Looking inside of the trapezium, where we have angle C and angle B, because those two angles are between parallel lines and they can see each other, they are co-interior. That means B plus C is equal to 180 degrees. From that, we can work out what C is in terms of B. So if we subtract B, we get C is 180 minus B. Okay, so now that we know what C is, we're going to put this expression into A add C. So A add C is now A add C. C is 180 minus B. Now the right hand side is still the same, 180. Now we can subtract 180 from both sides, so we get A minus B is equal to 0. Add the B to both sides, A does indeed equal B. End of proof. Next up, n is a positive integer, so a positive whole number. Prove algebraically that 2n squared times 3 over n add 6n times n squared minus 1 is a cube number. Okay, so there's only really one thing we can do to start this, and that is to expand the brackets. So 2n squared times 3 over n is going to give us 6n squared over n. Two n squared times n is going to give us 2n cubed. Now 6n times n squared is going to give us 6n cubed. And then 6n times minus 1 is going to give us minus 6n. Okay, so this first term, 6n squared over n, is 6n. Now we have 2n cubed add 6n cubed, that's 8n cubed. And then at the end we have minus 6n. The 6n's cancel and we get left with 8n cubed. Now to prove this is a cube number, we need to write it as a number times n all cubed, which luckily we can do because 8 is 2 cubed. So this finally is 2n all cubed, which is a cube number. K number 3, k is equal to n squared add 9n add 1. Mo says k will be a prime number for all integer values of n from 1 to 9. We want to show that Mo is wrong, and we must show that your value of k is not prime. Okay, so this is a disproving question. For once we are substituting numbers in, we need to find one value of n that makes k not prime. Okay, so let's start with n is 1. Okay, so that means then we're going to get k is 1, add 9, add 1, which is 11, which is prime. N is 2. It's going to give us 4, add 18, add 1, which is 23, which is prime. N is 3. It's going to give us 9, add 27, add 1, which is 37, which is prime. N is 4. Well, it's going to give us 16, add 36, which is 52, add 1, which is 53, which is indeed prime. Now, if you're not sure whether these numbers are prime or not, your calculator can tell you. I cover that trick in my secret calculator tricks, which I'll link down below. When n is 5, we are going to get 25, add 45, which is 70, add 1, which is 71, that is prime. When n is 6, we're going to get 6 squared, which is 36, add 9 times 6, which is 54, 36 add 54 is 90, add 1 gives us 91. Now, 91 is not prime. Now the way that we show that is that we can write it as a product of prime factors. So 91 is 7 times 13. So that means it has more factors than just 1 and itself, therefore it's not prime. Again, your calculator could have done this for you. Check out the trick if you don't know it already. Okay, number 4. Expressions for consecutive triangular numbers are n times n add 1 over 2 and n add 1 times n add 2 over 2. We want to prove that the sum of two consecutive triangular numbers is a square number. So, first up, if you're wondering what triangular numbers are, just as with square numbers, you can arrange into a square, triangular numbers can be arranged into an equilateral triangle. So, for example, 1 is the first triangular number, and then 3, and then 6, and it carries on like that. Next one would be 10. Okay, so the sum then means to add together, so we want to do n times n add 1 over 2 add n add 1 times n add 2 over 2. So okay, now because they are both over 2, we can write this as a single fraction. So we're going to have n times n add 1 add n add 1 times n add 2 all over 2. Now we're going to expand the top, so we're going to get n squared add n, and then n add 1 times n add 2 is going to be n squared add 3n add 2 all over 2. Now simplify the top, so we have n squared add n squared is 2n squared, n add 3n is 4n, and then add 2 at the end, all over 2. Now that's nice, everything here then has a common factor of 2, so we can divide that away, and we're going to get n squared add 2n add 1. Now, to show that that is a square number, we now need to factorize it. So this is n add 1 times n add 1. Which we can write as n add 1 squared. And that is our square number. In number 5, we want to prove that the square of an odd number is always 1 more than a multiple of 4. Alright, 4 marks. So, not much to go on here. First of all, we need to define an odd number. So, if we let n be integer, And then 2n is even, and 2n add 1 is odd. So there is our odd number, 2n add 1. Now we want the square of that. So 2n add 1 squared. Remember, means 2n add 1 times 2n add 1. Now, make sure you can expand that to get 4n squared add 4n add 1. Now, we could write this as 4 lots of n squared add n add 1. So, here is our multiple of 4. And then the plus 1 gives us our 1 more than the multiple of 4. So, job done. Okay, number 6. Prove algebraically that the difference between the sums of two consecutive odd numbers is always a multiple of 8. Okay, so again, we really need to define n as an integer. So, when n is integer, well, 2n add 1 is odd. Now remember, odd numbers are 2 apart, so the next one will be 2n add 3. So 2n add 1 and 2n add 3 are consecutive odds. Okay, so we want the difference between their squares. So we need to do 2n add 3 squared minus 2n add 1 squared. Okay, now remember, these mean 2n add 3 times 2n add 3 and 2n add 1 times 2n add 1. So make sure you can get 4n squared add 12n add 9 minus, now in brackets, 4n squared add 4n add 1. Okay, so we now have 4n squared minus 4n squared, so they cancel out. We have 12n minus 4n, that's going to give us 8n. And then we have 9 minus 1, which is 8. Now we can write this as 8 times n add 1. Therefore, that is a multiple of 8. So, job done. Another thing you can put at the end of a proof is Q, E, D. Quite enough done. Okay guys, that's all the fun for this video. Really hope you found it useful. If you have, don't forget to give us a thumbs up, get subscribed, share with your friends. If you have any requests for topics you want done like this, let me know down below in the comments. There is a playlist full of higher past paper exam questions like this, linked in the description, so take a peek, see what's there. For now, take it easy, take care.